A vast scene is unfurling as we talk, enthralling stargazers around the world. Betelgeuse, the hypnotizing red supergiant that embellishes Orion's shoulder, is going through a noteworthy transformation. This heavenly Goliath, known for its splendid red shade, has been a foundation of the winter sky for centuries, drawing the amazement and wonder of stargazers from old civilizations to current cosmologists. What makes this change so phenomenal isn't simply the changes happening inside the star itself, but the sheer scale and velocity with which they are occurring. This huge star, many times bigger than our sun, is showing us just how dynamic and unpredictable the universe can be. Betelgeuse's radiance, the brilliant glow that defines its heavenly presence, has flooded past its standard brightness by an astonishing half. Imagine a light suddenly burning twice as bright, projecting its sparkle further and with greater force. That is what's happening with Betelgeuse on an infinite scale. At the beginning of this year, Betelgeuse proudly held the famous title of the 10th most brilliant star gracing our nighttime sky. Its consistent, recognizable light was a constant in the night sky, a reference point of dependability. Anyway, this unexpected heavenly spark-up has propelled it to a renowned new position, now shining brilliantly as the 7th star in our dazzling evening sky. This jump in brilliance has sparked excitement and interest within the galactic community, prompting new observations and studies to understand the factors driving this sensational change. Betelgeuse, a huge star in its late phases of life, is of monstrous size. Its dimensions are so vast that if it were situated at the center of our solar system, it would stretch as far as Jupiter's orbit. Eventually, this star will go through a breakdown, resulting in a powerful cosmic explosion, which may lead to the formation of either a neutron star or a black hole. The anticipation surrounding Betelgeuse's cosmic explosion comes from the fact that it will be a phenomenal event, situated about 650 light-years away. Humankind finds itself in an ideal position to observe this vast exhibition firsthand. When the heavenly blast happens, it will deliver an amazing display of light. At first, there will be an unexpected flood of neutrinos that will sweep across the Earth, noticeable by observatories globally. Following this, high-energy photons will escape from the growing cloud of heavenly debris. Betelgeuse will quickly escalate in brilliance over the course of 7 days, reaching up to 100,000 times its normal glow. Depending on the blast's power, this divine signal could rival the brilliance of a full moon and could even be visible during daylight hours, casting distinct shadows at night. This great event will last for a prolonged period, offering a unique opportunity for detailed observations and possibly historic discoveries. While the cosmic explosion of Betelgeuse might provoke speculation and fear due to the historical association of such events with ill omens, we can take comfort in the fact that we are safely positioned at a significant distance, protected from any harmful effects. To fully grasp the mystery surrounding Betelgeuse, it is essential to return to the end of 2019 when particular peculiarities began to emerge. During this period, the red supergiant star began experiencing significant dimming, a change noticeable even to the naked eye. Observations using the Very Large Telescope in the optical range revealed that Betelgeuse appeared largely unchanged, yet its photospheric layers showed signs of major disturbance. The photosphere represents the outer layer of the star where light is produced. Scientists also identified an expansion of the photosphere, giving the impression that the star was expanding. When viewed from Earth, this expansion continued at a steady rate of about 8 kilometers per second for most of the year, until mid-November 2019. At that point, the outward speed began to decline. By mid-November 2019, the flow of material from Betelgeuse stopped, prompting astronomers to capture new optical images of the star. Their observations uncovered 2 remarkable inconsistencies. Firstly, an obscured region appeared in the star's southern hemisphere, creating a striking contrast with a previous image taken at the start of the year. Secondly, the surface temperature of the star underwent a plunge, dropping roughly 80 Kelvin between January 27 and February 13, 2020. The brilliance of Betelgeuse reached an extraordinary low. Approximately a year after the suspension of the surge, the star gradually recovered its brilliance over the next months, eventually returning to its usual magnificence. This led to the question, what had really occurred with Betelgeuse? all the available evidence strongly suggested that Betelgeuse had gone through a colossal and rare event known as a surface mass ejection, SME. This phenomenon bears similarities to coronal mass ejections, CMEs, seen on the Sun. To better understand SMEs, imagine a volcanic eruption on a scale matching that of a star. Material from the star's interior floods outward, causing shock waves within its atmosphere. Over time, this material forms particles and dust, partially obscuring our view of the star and making it appear dimmer. In the case of Betelgeuse, the SME resulted in the release of a mass 400 billion times greater than what is typically seen during similar events on other stars or CMEs. This amounted to several times the mass of the Moon, ejected at astonishing speeds. Scientists observed that such a massive mass discharge from a star's surface had never been seen before. The event allowed for direct observation and analysis of surface details using the Hubble Space Telescope, providing a rare glimpse into the aging and evolution of a dying star. The SME had a major impact on Betelgeuse, causing it to lose a significant amount of mass in a single event. This demonstrated that a dying star can experience major mass loss beyond its normal annual decline due to solar wind. In a way, it was as if Betelgeuse had forcibly expelled its outer layers and was once again in the process of slowly recovering from the aftermath of this event. However, following this dimming event, the star's behavior underwent a change. Previously, it would pulse or vary its brilliance at regular intervals. But now it is pulsing at irregular intervals. Betelgeuse is classified as a semi-regular variable star, meaning it experiences multiple cycles of fluctuating brightness due to changes in its size and temperature. This red supergiant is known to exhibit two primary periods of light pulsation. The first period lasts 400 days and is believed to be caused by pulsations in the fundamental mode. The second period is a longer pattern of about 5.6 years, and its origin remains unclear. In their research, scientists used virtual simulations to gain a deeper understanding of the events that occurred. They proposed that an unusually hot gas current, resembling a large and extraordinary bubble, rose from within the star. These events of hot gas bubbles occasionally arise due to the star's convective envelope, which can be compared to a pot of boiling soup, where the material is constantly moving and mixing. As this hot bubble rose and broke through the star's surface, it triggered the release of heavenly material. Interestingly, it also disturbed the star's normal pulsation pattern. The star's surface continued to expand while its deeper regions contracted, causing the star to shift from its usual 400-day pulsation to a new 200-day pulsation. Astronomers expect that the star's normal cycles will gradually stabilize, with the irregular pulsations likely returning to the usual 400-day cycle over the next 5 to 10 years. As for the possibility of a Betelgeuse cosmic explosion, astronomers speculate that it could happen at any time within the next 10,000 to 100,000 years, based on factors such as the star's color, brightness, size, and estimated age. Researchers suggest that Betelgeuse is currently in the early stages of helium to carbon fusion. This process will continue through oxygen, silicon, and finally iron, before the star's core collapses under its own gravitational pull, leading to a catastrophic explosion. Since Betelgeuse is located 650 light-years away, any cosmic explosion occurring now would only become apparent to us 650 years later due to the limitations imposed by the speed of light. Therefore, it is highly unlikely that we will witness the star's dramatic destruction during our lifetime. The remarkable thing about Betelgeuse is that we can actually observe its surface, which is not typically possible with most other stars. This gives us an incredible opportunity to learn more about how large stars like Betelgeuse behave as they age, including events like these extraordinary mass ejections. Recently, astronomers made a startling discovery. They noticed a star consuming its own planet 12,000 light-years away in the constellation Ia. Betelgeuse, with its captivating name and prominent position in the night sky, has intrigued the human imagination for centuries. Its significance extends beyond scientific knowledge, as it has influenced pop culture and folklore around the world. Betelgeuse has a rich and diverse origin, rooted in the Arabic language. Originally translated as the armpit of the giant, some researchers argue that it may refer to a hand or shoulder instead. This physical association is reflected in various interpretations of Betelgeuse, often linked to human or animal figures across different cultures and legends. Betelgeuse carries complex meanings and symbolism. In ancient Japan, it represented a severed limb, while in Brazil, it was seen as a turtle's leg or a caiman's hind leg. The Sanskrit word for Betelgeuse means the damp one, tied to Hindu astrology's Ardra lunar house, and associated with the storm god Rudra. Since ancient times, Betelgeuse has played an important role in cultural practices and rituals. For example, in Macedonian tradition, it represented domesticated animals and agricultural life in villages. In other regions, such as North Baffin Island and Melville Peninsula, its rising marked the beginning of spring and longer days. Betelgeuse's cultural prominence stems from its association with the constellation Orion, where it is recognized as the star on Orion's right shoulder. As one of the brightest stars overhead, ranking 11th in luminosity, it dazzles and inspires artists, writers, and producers. Betelgeuse, also known scientifically as Betelgeuse, continues to captivate astronomers and enthusiasts alike with its new transformation and the potential for a future cosmic explosion. Positioned prominently in the constellation Orion, Betelgeuse has been a celestial symbol for centuries. Its reddish glow and variability have captured the imagination of cultures worldwide. In recent astronomical history, Betelgeuse's erratic behavior has been particularly significant. Its variability and brightness have been closely observed, revealing insights into the late stages of massive star development. This variability, once thought to follow a predictable pattern, has astonished cosmologists with its recent shifts in pulsation periods and extraordinary dimming events. One of the most significant observations in recent years was Betelgeuse's dimming event that began in late 2019 and continued into mid-2020. This dimming caught astronomers off guard, as the star lost a significant amount of its usual brilliance. The fading was not only visible to the naked eye but also measurable through precise observations using advanced telescopes. Such events are rare for a star of Betelgeuse's size and have prompted intensive studies to understand their underlying causes. Scientists have proposed several theories to explain Betelgeuse's dimming episodes. One leading theory suggests that the dimming could be linked to the release of material from the star's surface, potentially caused by convective cycles deep within its interior. These cycles, likened to enormous bubbles of hot gas rising through the star's layers, can disrupt its regular pulsation and lead to the ejection of celestial material into space.